Alright, so this is the Colby-Schmidt reaction. We're just gonna make salicylic acid. So right here we're gonna have a phenol. A phenol is very stable, and its KQ or pKa, sorry, is equal to 10. So our first step, we're gonna do acid base. So we're gonna have hydroxide come take a proton. This is the most acidic proton right here. I mean, it really is the only one to take also. So the KQ difference is so little. The KQ is equal to, I mean, the pKa of water is 14, so it's going to be equal to 10 to the 4. So forming water, so just in general, if the KEQ difference is over 1,000, then it's going to go forwards. So now we formed phenoxide. Phenoxide is the opposite of phenol. It's unstable, all that. So now what's going to happen is we can form resonance right here. So we can push electrons. We'll just put electrons right here, and this is going to go onto here. So now we're going to, so this step right here is destroying the aromaticity. So this molecule is no longer aromatic because each molecule or each atom does not have a p orbital. Right here, this is, honestly, I don't know what it is. It's not. It's definitely not. Honestly, I'm not gonna tell you. I'm not gonna say wrong information. I don't know what it is, but the molecule is not aromatic. Okay, so now it's gonna react with carbon dioxide. So if I use a different color, carbon dioxide is Sp. Wait, did I write it? Doesn't matter. It's gonna attack it. So there's negative charge right here. It's gonna go onto the carbon. It's basically nucleophilic addition. That's how I remember it. So basically, we're forming a new carbon-carbon bond, and this step is basically restoring aromaticity. So you basically it's gonna go forwards because the reaction, it wants to restore aromaticity. So um wait, no, I'm pretty sure, no, this is not the, I'm sorry. This step isn't restoring aromaticity. Just forget about all that aromaticity crap for a second. Just draw what you see. Just draw what you see already. Um we formed this carbon, and now there's an O on that, and then this is obviously, this is gonna be negative, and this right here is that. So this is our molecule right now. There's a there's a hydrogen right here. So this is the part you need to lock in on, because this is the part where if you don't remember, you're not gonna remember on the exam. So right here, hydroxide, again, hydroxide attacked in the first step, and he's gonna attack again here. So he's gonna come and he's gonna attack this, or he's gonna, yeah, he's basically gonna take this hydrogen. We're gonna push this bond here, push this right here, and this is gonna go onto the oxygen. So now we formed our, this step is, so we could put backwards arrows like this, but this step is definitely gonna go forwards. I mean, I'm gonna put the arrows either way. I still don't know to this day whenever to put whatever, like single arrow or double arrow. But the point is, the reaction is definitely gonna go forwards because the driving force is the restoration of aromaticity. So now aromaticity is restored. So now our final step is acidification. So whatever you see that has a negative on it, just add a H. You don't need to show the steps. You don't need to show any mechanism for this. Just show that, because if you were like to add hydroxide on each step, you're gonna have like two arrows. It's not clean. So just, just make it like this. Okay, so we formed salicylic acid. Does that look like our answer? Yep. Oh shoot. Oh, good thing I made didn't. Oh shoot. Wait. No, this is correct. I'm bugging. Yeah, no, this is definitely correct. It's just the answer looked a little bit different. So let me make the answer look like yeah. Let me make the answer look like the one I have on top. For a second, I really thought I did it wrong. Okay. Um. Yeah. Okay. The question is, why is it? ortho and not para. If you remember ortho, it's just next to the group. So right here, there's an intramolecular like hydrogen. It's stabilized by the intramolecular right here. That's it. If you have a question about that, that's the answer. It's just stabilized by the intramolecular hydrogen.